With that on there, I can do a little walking around the floor. See that?
Yeah.
I can be a little free.
Yeah, you can still be
A little bit like that, okay.
Do you want me to clear some of that off? Do you want some of that space?
Well, actually, I guess we have most of the people here, don't we?
Yeah, we'll probably have them filing in for another 15 or 20 minutes, but not too many.
Well, for right now, let's just leave it up there,
Okay.
as long as it's not gonna.
I tell you what, before I go, I'll clean it off.
Well,
Probably.
if you don't do it, I will. So
Okay,
no
well, I
big deal.
mean, I'm here until 6. Like I said,
Oh,
my wife's
okay.
not picking up till then, so you're stuck with me.
I think I'll get started.
Go down to the side and then I'll join you.
Okay. All right, can you hear me okay? All right, listen, I'm going to get started. My name is Ross. I'm your helper today. My goal is to see that you do as well as you possibly can on the NLN test. The packet that you received today are basic arithmetic skills that you don't use every day. But on the NLN test, they're going to want to know that you basically understand these basic skills. And, pardon? So what we're going to do is go over some basic skills with you. My goal is to make things as clear as possible. And I understand that some of you probably know most of this. Some of you may not know much of it. Some of you may have forgotten it. It's kind of a mixed bag. So my goal is to help you all I can. Now, when you take the NLN test, the more you know, the better your score. That's a fact, and of course you probably know that. Well, tonight is the 7th of February. We're going to do arithmetic basic math tonight. 2 weeks from tonight, on the 21st, we're going to do some basic algebra skills that can help you to do your best. And so my goal is to do this job the best I can. This format is new to me. I'm not used to having stand up here. I'm more of a move around type teacher, but we're going to make the best of this situation. I'm going to make it as clear as I possibly can to you. So your close attention to details can make a great big difference in your score on the NLN test. We want you to make sure that you've signed in and that you have taken an evaluation form that you can turn in at the end of the session. And you can just bring your evaluation forms down and put them on the desk here. That's to help us understand whether or not we're getting the best results possible in our attempts to help you. Okay. Now, one of the first things I do is talk about terminology. And what I'm going to do is I'm going to do some talking, and then I may have you do some problems right out of this packet here, just to be sure you understand what you're doing. The goal would be for you to understand what you are doing. Now, I have some terminology here that I want to be sure that all of you understand. And the words that like the word is means equal. The word and means plus. So if I said 2 plus 3 is 5, I would just as well say 2 plus 3 equals 5. Is means equal. When you hear it in math, one thing I hear is students telling me word problems. Gee, I don't like word problems. Well, I don't like them either. But if you understand the words, it helps you a whole lot. The word is means equal. The word and means plus. 2 and 3 means 2 plus 3. The word and means plus. Are you with me? And of. How many people know what the word of means? Say it. Right. In case you aren't sure about that, you see what I have here? What would 4 of those be worth? What did of mean? Multiply, yes. Of means multiply. So in math, when you hear the word of, you can think multiply. Now, sum difference product quotient. Sum difference product quotient. Are you listening? The word sum has a meaning. The word difference has a meaning. The word product has a meaning, and the word quotient has a meaning. What do I mean by the word sum? Who knows what I mean to say find the sum? What am I asking you to do? Find the addition, right? What if I say, tell me the difference? What am I asking you to do? Subtract, that's right. What if I say, give me the product? What am I asking you to do? Multiply. And what if I said, tell me the quotient? What am I saying to you? To divide, that's right. Now, 6 plus 2 equals 8. 8 is the sum. Are you with me? 8 is the sum. 6 and 2 are called addends. In case you are ever asked, a number that you add is called an addend. Is that clear? All right, 6 minus 2 equals 4. That is called the difference. Don't worry about what 6 and 2 are called. Not too important. We won't fuss with that one, okay? 6 times 2 equals 12. Now, the dot means multiply, doesn't it? Y'all ever see that dot before? You could just as well say 6 2 both in parentheses. That also means multiply, doesn't it? 6 and 2 are called factors, in case you did not know. 6 and 2 are factors, so the product of 6 and 2, when I want to say multiply, I could use an x as well. You understand me? But in algebra, since we use the letter x, sometimes we don't use the x to signify multiplication. And 6 divided by 2 is 3. That's called a quotient. Are you with me? Now, to show division, you can do it this way. You can do it this way as a fraction. A fraction means a division. And you can do long division style. They all mean the same thing. Now, who understands these words here? Do you all understand them? Because I want you to understand them. Let's see if you do understand them. Who can tell me the sum of 10 and 5? What's the sum of 10 and 5? 15. Right. What's the difference of 10 and 5? What's the product of 10 and 5? And what's the quotient of 10 and 5? There you go. That's right. So when you see the word sum in a word problem, that means to add them. In algebra, if I was saying, what's the sum of 5 and x, you would simply write 5 plus x. You couldn't write a single number for that because they're not the same thing. Do you follow me? Okay. Now, in math, we call our number system the decimal number system. Have you all ever heard that before? The decimal number system? I'm making noise here, aren't I? I better quit that, hadn't I? Don't go reporting me, all right? All right, the decimal number system. December used to be the 10th month in the calendar. DEC means 10. A decade means 10 years. A decathlon is 10 events in the Olympics. Do you understand me? DEC means 10. We have what you call the decimal number system, meaning everything is multiplied by 10. You've got your ones place, your tens place, 10 times 10 is a hundreds place, 10 times 100 is 1,000 place. You all know what I mean by place value? Sure you do. Why is it that mankind has a base 10 number system? Who knows why? I see some people know why. You can show me why, can't you? Can't you show me why? Tell me yes. When the caveman got out of the cave, they started counting the goats, am I right? And the way they counted them was on their fingers. So we have 10 fingers, right? Better not do this, get by trouble here. Anyhow, if we were Alf, we'd have a base 8 system, wouldn't we? But we're not Alf, are we? We're humans, so we have a base 10 number system. So every number up there has a meaning. The 3 stands for thousands, the 1 stands for hundreds, the 9's for 10, the 2 for 1. Have you all ever had 73 cents worth of change in your pocket? Have you? Have you ever had 73 cents? How can you make 73 cents? Say 7 dimes and 3 pennies. Say it. A dime. Hey, a dime. You ever have a dime? Oh, I wish I did, right? What fraction of a dollar is a dime? 1/10, right? What fraction of a dollar is a copper? Not a copper, a penny. I'm sorry. I'm getting wrong here. What fraction of a dollar is a penny? Oh, 100th, right? Yeah. So everything is based on tens. Now, if I said 73 cents, what fraction of a dollar is 73 cents? What fraction, listen to me, I'm talking to you. What fraction of a dollar is 73 cents? 73 over 100, because there's 100 pennies in a dollar, right? So 0.73 means 73 over 100. Do you understand? Now, if I gave you 1 penny tonight because you didn't do your homework, I wouldn't even give you that much, would I? But 1 penny, 0.01, right? You ever buy sucker at the store for a penny? No, you're too, they cost too much, don't they? 0.01. What does 0.01 mean? Say 1 cent. 0.01 means 1 cent, means 1/100th of a dollar. 1 cent is 1/100th of a dollar. Well, listen, a 2-place decimal is hundreds, right? What's 0.25? What's 0.25? 25 100ths, right? Isn't that a quarter? If you reduce your fraction, right? You all ever have a quarter in your pocket? Here you did. What would 0.9 be? What would 0.9 be? 9/10. A 1-place decimal is tenths. A 2-place decimal is hundredths. Okay. Anyhow, this is our decimal number system. 0.7 would be 7/10. 0.5 would be 5/10. Could you all reduce 5/10? Say 1/2. Did you know that 0.5 and 1/2 mean the same thing? Don't they? Okay. 0.80 would be 80 hundredths, would be 4/5. I'll get to that later. 0.25 is a quarter, reduced down to 1/4. Okay. Who understands our 10-place decimal system? Are we clear on that? Yeah, I just want you to be clear on that. Now, when y'all go to Publix to buy your groceries for dinner, and you get a receipt, don't you? And on that receipt, they add up all that you bought, right? And when they add up those decimals, what's the important thing to notice? The decimals are what? Lined up, aren't they? Yeah. So when you add decimals, you line them up. Okay. All right. With fractions, I want you to understand a few words here. Do you all understand what I mean by numerator? Numerator is the top part of a fraction, and denominator is the bottom part of a fraction. Is that clear? Okay. Five eighths. What's the denominator in 5/8? 8, right. What's the numerator in 7/11? That's right. Numerator, denominator. Do you all know what I mean by a mixed number? A mixed number such as 2 1/2. Do you understand me? If I give you 2 1/2 apple pies, would you understand me? I'm not going to do it, but would you understand me if I did? I will do it if you want me to, but probably won't. 2 1/2 apple pies. Can you all see that? Do you all see 2 1/2 apple pies? How many halves are 2 1/2? Look and count and see. How many halves are 2 1/2? 5 halves. Do you all see 5 halves there? When you have a mixed number, you say 2 times 2 is, plus 1 is 5 halves. You all see that? When you have a mixed number, you can turn it into what we call an improper fraction. Improper fraction. Who could tell me what would 3 1/2 pies equal to if I ask you for $1 million right now? If you can tell me this. Well, I'm not going to give you $1 million. I'm just lying my head off here. But 3 1/2 can be turned into an improper fraction. What would you say 3 1/2 is equal to? 7 halves. Good job. Now, so you can take a mixed number and turn it into an improper fraction. Did you hear me? When I say improper fraction, what I mean is that the top number is bigger or as big as the bottom number. Any fraction where the top number is as big or bigger than the bottom number is called improper. 3 2/3. 3 times 3 is 9, plus 2 is 11/3. Who understands how you can do a mixed number into an improper. Do you see how that works? All right. If I give you an improper, you can change it back into the mixed. Say improper to mixed. Say that. Top divided by bottom. Say it. Every fraction is top divided by bottom. So 5 divided by 2. Do you hear me? 5 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4, with 1 left over, 2.5. Are you with me? All right. 21 over 10. Say improper. Who can tell me 21 over 10? What's my mixed number? 2 and 1 tenth. Who understands that? Behave yourself. My arm can't go up. Tell it not to go up there. Okay, look here. 6 and 1/4. I'm listening. 25 over 4. Do you all see how to do that? 18 over 2. Say improper. What's the mixed number? Say it isn't mixed. Just say 9. Do you all understand that? Is that clear to everybody? Okay, these are terms that I want you to understand. Okay, here's another thing I want you to understand. Percent. Now that term comes up a lot. I want to fix this where I can see this good. Hold on. Just give me a check. You know I'm new at this, so don't get too uppity with me here. All right. Percent. Percent. Per gallon. Per means out of. Cent means 100. Percent. Out of 100. Percent means out of 100. Do you hear me? Percent means out of 100. 50% means 50 out of 100. Are you with me? It means 50 over 100. Are you with me? You like? No, don't answer that. 50 out of 100 is the same as a half, right? 50% means 1/2. Are you with me? Because you can take your number and put it over 100. If I said 70%, wouldn't that be 70 out of 100? Or 70 over 100? Now listen, 50% can also be called 0.50. What's a 2-place decimal, class? Say hundredths. So 50% could be thought of as 0.50. Does 0.50 mean 50 over 100? Doesn't 50 cents mean 50 out of 100 pennies? So 50% can be thought of as 50 out of 100 or 0.50. Are we clear? Now here's the deal. When you want to do a percent to a decimal, you drop your percent sign, move the decimal 2 places to the left. Now look at me when I'm talking to you so you're sure about this. 50%. If I drop my percent sign, I see the number 50, don't I? Where's the decimal in a number when I don't see it? Now look here, when I say 50, where's the decimal in a number when I don't see it? At the end of it, on the right-hand side. If I move that decimal 2 places to the left, don't I get 0.50? See what? That's the deal. When you have a percent, you want to turn it to a decimal, you can drop your percent sign and move the decimal 2 places to the left. Does that make sense? Okay. 100%. If I drop the percent, I see the number 100. Would there be a decimal at the end? Say yes. And if I move it 2 places to the left, what do I get? 1 whole. If you eat 100% of your supper tonight, you eat 1 whole complete supper. Do you understand me? 100% means everything. It means one whole thing. If you get 100% on your test, you did one whole test correctly. Are you with me? 100% means you did one whole thing right. If you tell your children to go mow the lawn, and they do 100% of the job correctly, it means they went and did the whole lawn and mowed it. They're done. Do you understand what I'm saying? When you have a percent, you can turn it into a fraction by simply placing over 100. Does that make sense? And then you can reduce your fraction. 20%. Look at me when I'm talking to you here. 20%. Who can tell me the fraction? 20%. What's my fraction? Reduce that down, please. 1/5. Who understands that? 20% is equal to 1/5. Okay. Now, 20%. What's my decimal? 0.20. Who understands that? Are you with me? Good. Okay. Now, supposing I give you a decimal. Supposing I give you a decimal. Supposing I say 0.35. 0.35. Doesn't that mean 35 over 100? Wouldn't that mean 35%? So when I give you a decimal, like 0.35, all I got to do is move the decimal 2 places to the right and add a percent. Does that make sense? Yeah, good job. 1.7. Who can turn 1.7 into a percent? Who can turn 1.7 into a percent? 170%. Do you all understand? If it's over 1 whole, it's over 100%. If it's under 1 whole, it's less than 100%. There you go, percent. Who's with me on this here? Okay. Another thing I want to touch on before I start doing a few problems with you is the basic idea of the metric system. One thing nurses and medical technicians have to understand is a basic idea of the metric system. Because when I go to the hospital and you're going to give me my medicine, I want you to be sure to give me the right medicine. You got to know how much to give me. You don't want me to float away, do you? No. So you got to be able to deal with your metric system here. I want to help you out here. When my son was in the 8th grade, he taught me this because his teacher taught it to him. And you know what? It made it real to me. My little 8th grade son, when he was back in 8th grade, he taught this to me. He told me this. Now you listen to me while I'm talking to you, so you'll catch on to it here. King Henry died Monday drinking chocolate milk. Now, did you hear me? King Henry died Monday drinking chocolate milk. Now, I think that's pretty clever. You know, King is important, Henry's important, and dying is very important. Therefore, they're capital letters. Don't you agree? King and Henry and dying, aren't they all important? Therefore, capital letters. Drinking chocolate milk is kind of minor, isn't it? It's not a very important thing. So those are lowercase letters, drinking chocolate milk. Well, this is your metric system rolled up into a little story here. Now listen. Kilo, hecto, deca. Have you ever heard those words? Kilo, hecto, deca. Meters, liters, grams. In metrics, we generally use to talk about meters. Meters is about a yardstick. Liters is like a quart bottle of milk. And grams is a unit of weight, a little teeny unit of weight. Deci, centi, milli. Who understands? Deci is a tenth, centi. You know, it's based on groups of 10, just like our decimal place value system. It's based on units of 10. and it's very, very nice. I fought it forever till my son taught me how to do it. Here's the way it works. Here's the way it works. On Monday, I ran 5 kilometers. No, I didn't. I'm just telling you the story. Don't believe it. I ran 5 kilometers. I ran a 5K race. Now, in England, a kilometer is sort of like our mile. They drive kilometers in England. A kilometer is less than a mile, but it's a unit of measure. A kilometer, kilo means 1,000. Say kilo, 1,000. So when I say kilometer, I mean 1,000 meters. A kilometer is 1,000 meters. Is that clear? So if I ran 5 kilometers, I ran 5,000 meters. Are you with me? 5 kilometers means 5,000 meters. Are you with me? If I wanted to change 5 kilometers to meters, I would move 1, 2, 3 spaces to the right. Say 3 spaces to the right. Now, when I move this decimal 3 spaces to the right, and it was there, and I moved it 3 spaces to the right, and that makes 5,000 meters. It makes 5,000 meters. Are you hearing me? So if I wanted to change kilometers to meters, I'd move my decimal 5 places to the right. Okay? Now, what if I said, I'm going to walk 1,000, my pencil's messed up here. If I'm going to walk 1,000 meters, say 1,000 meters, I want to change it back to kilometers. I move my decimal 3 spaces to the left, and I have 3 kilometers. So moving back and forth on that metric line changes your units. You hear me? Say 4 hectoliters. Say 4 hectoliters. Say it. 4 hectoliters. Say 4 hectoliters. Hecto means 100. A hectoliter is 100 liters. Is it more than a liter? Yes. 100 liters is more than 1 liter, isn't it? So if I have 4 hectoliters, I can turn it into liters by moving 1, 2 spaces to the right, and I would have 400 liters. 400 bottles of milk. Liters. You understand me? If I say 1, my pencil is really messed up big time. Oh, here, I got a better one. Okay. Now, if I said to you, let's say, I say, here's 1 meter. Say 1 meter. I'm going to ask you, how many centimeters is 1 meter? Say centimeters. Say 1 meter to centimeters. Say that. And if I'd have to move how many spaces to the right from 1 meter here, I'd have to move 2 spaces to the right. Right? Wouldn't you say that's 100 centimeters? You see what I did? I moved it to the right, didn't I? Do y'all see that? What if I said 300 centimeters, and I wanted to convert back to meters? I'd move my decimal 2 spaces to the left, and that would be 3 meters. So my point being, you can move left or right on that line, and all you're doing is moving your decimal. Does that make enough sense? Who sees what I'm talking about? Please raise your hands if you're kind of catching on to that. You see? Now, in nursing, you're going to be changing grams to milligrams, centiliters to liters. You know, if you're drawing blood or you're giving me the dose of medicine so I don't die, you're going to have to give me the right medicine, right? And if you don't know how to do it, I'm going to end up at the Aycock Funeral Home, and I don't want to do that. So you got to put it, you know, you got to be able to handle your metric system. Is that clear? Okay. Another thing that they're going to want you to understand, let's see who understands this. They're going to give you some geometric figures, and let me just give you a little, show you what they're talking about. Something like this here. Here we have a rectangle, 2 inches by 4 inches, a 2-inch by 4-inch rectangle. Now, a 2-inch by 4-inch rectangle, if I said, could you tell me the perimeter? You might be able to say yes, or you might not be able to say yes, but you'd have to do it for the test. If they're asking for the perimeter, you would want to add up all 4 sides. Do you understand? Perimeter is your distance around. Is that clear? So the perimeter here would be 2 plus 4 plus 2 plus 4, or 12 inches. Do you all understand that? Perimeter means distance around. Is that clear? But when they talk about area, they're talking about how big is the inside. How big is the inside? That's what they're talking about. Now look here. Tell me something. Look, I'm going to draw something on the air here. 1 inch, 1 inch, 1 inch, 1 inch. What would we call a 1 inch, 1 inch, 1 inch, 1 inch? What would we call that? 1 square inch. Do you understand me? 1 by 1 by 1, 1 square inch. Now the area of this rectangle is 8 square inches. Do you all understand me? The area is 8 square inches because you multiply length times width and you get your 8 square inches. Do you all see that? Does that make sense? All right, let's see if you know what I'm doing here. See if you know what I'm talking about. Now, I'm going to say it out loud. I'm not going to draw a picture. You all have to think about this here. A 6-inch square. Who could tell me the perimeter of a 6-inch square? Huh? 24, because you'd add 6 plus 6 plus 6 plus 6, right? So the perimeter of a 6-inch square would be add 6 4 times 24 inches. What would the area of a 6-inch square be? 36 square inches. So understanding the difference between perimeter and area is a big deal. Okay? Okay. Okay. Then they're going to bring in triangles and other kinds of geometric figures, but here's another figure they're going to talk about, and they're going to talk about a circle, and you want to have a basic understanding of a circle. With a circle, from the center to the side is called the radius. Are you with me? A circle from the center to the side is called the radius. And the segment that passes through the center and touches the circle in 2 places is called a diameter. Does that make sense? You ought to know those terms, radius and diameter. Diameter is the bigger of the 2. Is that clear? Diameter, radius. Okay. Now, it's true that, listen to me, in all circles, I'm going to write this on the paper here, the circumference, which means the distance around the circle. It's like the perimeter of the circle. Circumference is the perimeter of a circle. It's the distance around the circle. Circumference is always about 3 times the diameter. Always about 3 times the diameter. So if I had a circle with a 10-inch radius, or diameter, about what would the circumference be? About 30 inches around. Because your circumference is always about 10 times the diameter. The formula is pi d. Now, pi is about 3. Pi is actually 3.14. 3.14, or for a fraction, they say 22/7. But look here. Pi is about 3. Pi is a little bit more than 3. Okay? You understand me? So when you want the circumference of a circle, it's about 3 times the diameter. And so you'd use that formula, pi d. Now let me ask you this here. Here's a question, see if you kind of catch it here. Our Earth that we live on right now, we're sitting on the Earth right now. You know that, don't you? But our Earth, from North Pole to South Pole, is 8,000 miles, right through the middle of the Earth. Right through the middle of the Earth, it's about 8,000 miles. Do you hear me? We have a great big ball we live on called Earth. And from North Pole to South Pole, right through the middle, is roughly 8,000 miles. Wouldn't that be the diameter? Wouldn't that be the diameter? Now, who could tell me what the distance around the equator would be approximately? 24,000 miles. Do y'all understand that? It's actually 25 plus, a little over 25,000 miles. Pi d, multiplied by 3.14. Okay? The area of a circle, whether or not they ask you this, is pi r squared. Don't ask me where they came up with this because it's not that important for you to know. But if you did want to find the area of a square, now squares, you'd have little pieces of squares in there, but if you multiply 3.14 times radius, that would be very close to the area of the square. Is that clear? Is that clear? Okay. Now, those are my basic kind of terminology and things that I want you to think about. And now, what I'd like to do is make sure that you can add, subtract, multiply, and divide fractions. Now, you know what? I deal with a lot of college students at the Mueller Center, and it's something that we don't do every day. We don't go around adding fractions. Do you go add fractions every morning? No. You all sit in the evening and before you watch Jeopardy and just add some fractions? You don't do that, do you? Kind of foolish, wouldn't it? What's 3/8 plus a fourth? We don't do that. But for the NLN test, they darn well want you to know how to add some fractions. So I'm going to go over some basic skills with you. And listen to me. When I'm through with you tonight, you can take this worksheet that you've got and you can practice. In fact, I'll give you some practice time in a few minutes here. But let's add some basic fractions right off the bat to make sure everybody's on the same page, so to speak. There's rules for adding fractions, there's rules for multiplying and dividing. What if I gave you a test right now and add, subtract, multiply, divide fractions, and I say you either get to eat supper or you don't, depending on your test score? Some of you might be a little bit hungry by the end of the night, right? My point being, if you listen to me, fractions are really simple. They're really not hard. And I want you to listen to me, and I want you to catch on, fractions are not difficult. I know all of you want to tell me, no, I hate fractions. I hear that all the time. But fractions are really very, very simple. Okay, we're going to get started here. And I want you to follow along with me. One thing I do, one way to think about fractions is using pizza pie. Everybody understands pizza, don't we? I mean, if you don't, I guess you're from a different country, because everybody on Friday night gets their pizza. All right, now, think about the pizza pie. We're going to add some fractions here. If I eat 3/8 of the pizza and what does and mean? And you eat 2/8 of the pizza. Now, if I eat 3/8 and you got anchovies on yours. Well, if I eat 3/8 and you eat 2/8 together, how much did we eat? That's right. So when you add fractions, boys and students, you must have a common denominator. Say, gotta have a common denominator. That's right. If I eat 1/8 and you eat 5/8, I'd call you a piggy. All right? If I eat 1/8 and you eat 5/8, let's look at that here. We'll draw another picture here. If I eat 1/8 and you eat 5/8, you're eating anchovies. Okay. If I eat 1/8 and you eat 5/8, how much did we eat all together? You ate 6/8. Now the deal is this. When adding fractions, you write down your common denominator, add your numerators. Now 6/8 of the pizza. Who could describe 6/8 differently? Do you see 3/4 there, class? 6/8 would be 3/4. Are you with me? Now what you're doing is you're reducing your fraction. Now here's the deal. To reduce, divide top and bottom by the same number. Say to reduce, divide top and bottom by the same number. What goes into 6 and also into 8? 2 goes into 6 3 times, 2 goes into 8 4 times. Are you with me? Okay. Now, if I eat a half a pizza and you eat 3/8 of the pizza, say you can't add those fractions. Say it. Because we don't have a common denominator. You can't add unless you have a common denominator. Do you understand me? You have to have a common denominator. Here's the deal. When you're looking for a common denominator, you always look at the bigger number. Always. When I'm looking for a common denominator, I look at the bigger denominator. What's my bigger denominator? And the question is, can I turn 1/2 into 8s? Yes, you can. Half a pizza. Now look at me. I'm trying to help you here. Half a pizza. You see, I'm making a half a pizza right here. How many 8s? 4 8s. You change 1/2 to 4 8s. Do you hear me? Look here. When you want to make equivalent fractions, you multiply top and bottom by the same number. You remember that skill? 4 times 2 is 8. 4 8s plus 3 8s would be 7 8s. Are you with me? Do you understand that? When you're looking for a common denominator, always look at the bigger one. Ask yourself, can the smaller one be multiplied to get the bigger one? Does that make sense? Who sees that idea? Are you with me? Let's try another one here. I'm looking for a common denominator. Say, find a common denominator. I can't add them as they are because I can only add with common denominators. I say, look at the bigger one. What is the bigger one? Can 3 go into 12? All right, now watch me here. 5 12s. Now 3 goes into 12. So I multiply top and bottom by 4, and I get 4 12s. Do you see that? When I add up, what do I get? There you go. I added my fractions. Now say reduce. You want to divide top and bottom by the same number. What goes into 9 and also into 12? 3 goes into 9, 3. 3 goes into 12, 4. Who understands that concept? You can add, you have to have common denominators. I'm going to try another one on you. This will blow your mind. You're going to think Ross is mean, but that's okay. Watch this here. 5 8s plus 1/3. Oh, good gosh. 5 8s plus 1/3. You got to find a common denominator. Say, find a common denominator. Say it. What's your bigger number? 8 won't do. Why won't 8 do? Because 3 won't go into 8. Do you understand? Okay. Well, once 8 won't do, you got to do multiples of 8. Say multiples of 8. What's 2 times 8? Would it do? Say no. Because 3 won't go. Say 3 times 8. What's that? Will it do? So we got to change to 24. Y'all with me? Who understands how I was adding those fractions and all I did was find my common denominator? Do you understand? Do you all see that? 1/2 plus 1/7. Who can tell me the common denominator? I'm looking at you. 1/2 plus 1/7. 14. You all see that you'd have to change them to 14. Does that make sense? Okay. Look here. You know what? Good. You can add fractions. It's beautiful. I love it. Look here. Adding and subtracting pretty much similar. Are you with me? Who's not? Who's still having? Oh, I can't read that. You all with me? Look here. Let's try it up here. Okay. There's 3/4 of a chocolate cake. Are you with me? 3/4 of a chocolate cake. What if I took away 1/4? Now think about that. 3/4, take away 1/4 is 2/4. So if I take away 1/4, the answer is 2/4, and it reduces to 1/2. Addition and subtraction are the same. In one you're adding, in one you're subtracting. Common denominators, you must have them. Who could tell me what would be my common denominator for 5/9 and 1/3? 9. Who understands how I was able to subtract those fractions? Do you see what I'm saying? Does that make sense? Hey, you know what? I'm going to tell you something here. You can get a common denominator by multiplying the two denominators. Listen to me. You can get a common denominator by multiplying both the denominators. What do y'all suppose the common denominator here will be? 40, sure. Who understands add and subtract fractions? Do you understand me? Do you understand that? Watch this here. One more I want to show you about adding and subtracting. 2 1/2 plus 3 5/9. Now watch me. I'm going to help you out here. Say add mixed numbers. Say that. Here's what you do. Now watch. It's real simple. I bring over my whole numbers, and I got to find a common denominator, which is 18. Are you with me? I had to do multiples of 9, and 18 works. You all see what I did? I added up, I got 5 and 19/18. Now look here. 19/18 is more than one whole, isn't it? Say 19/18 is 1 1/18. Do you hear me? 19/18 is 1 because 18 goes into 19 one time. So the answer will be 6 1/18. Who understands that? You all see how I did that? I subtract, same old, bring over the whole numbers, common denominator, the answer is 1/4, 1 1/4. Does that make sense? Huh? Does that make sense? Yes or no? Okay, here, I want to show you another one that might give you a little trouble. Watch this. Now look at the one I just put up there. 5 1/8, take away 2 7/8. Can you take 7/8 from 1/8? Say no. No. Say no. You can't take 7/8 from 1/8. Come on. You know that, don't you? Say borrow from the whole number. If I borrowed 1 from the whole number, I would borrow 1 whole. Say borrow 1 whole. And I'm going to rob Peter to pay Paul here. The 1 whole I will call 8/8. Isn't 1 whole the same as 8/8? What's 8/8 plus 1/8? There you go. You're so smart, I like it. You're making my job easier. It's 2 2/8 or 2 1/4. Okay, so much for adding and subtracting fractions. What does the word of mean? Say, look, I can't hear you. What does the word of mean? Multiply. Of means multiply. Now, I'm talking to you, and I want to have an answer to this question. I want you to answer my question. What does of mean? Okay. Of means multiply. What would 4 of these $5 bills equal? Of meant multiply. Here's a question I want you to think about. How much checker pie do you see there? How much checker pie do you see? Say it. A fourth. Okay, say a fourth of a checker pie. Say it. What if I said you can have half of that fourth? If I said to you, you could have half of the fourth, would you understand me? Of course you would. If I said you could have half of the fourth, wouldn't you get out the knife? Huh? And wouldn't you cut it in half? Now, what is half of a fourth? Now, come on. What's half of a fourth? You all see that? Say half of a fourth is an eighth. Say that. There's your checker pie. Half of a fourth. Half times 1/4 is 1/8. What does of mean, people? Right. Half times a fourth is an eighth. I multiplied fractions right in front of your face there, didn't I? I'm getting a tingle in my ear here. I better go home and eat my dinner. I'm hungry. Half of a fourth is an eighth. When you multiply fractions, you do not need common denominators. You do not need common denominators. Half of a fourth is an eighth. When you multiply fractions, it's top times top, bottom times bottom. When you want to multiply fractions, it's top times top, bottom times bottom. Does that make sense? Can you all handle that? What's half of a fourth? Okay. Let me ask you this. What's half of a half? That's right. So when you multiply fractions, you just multiply straight across. Say multiply straight across. When you add fractions, you need common. Right. When you multiply fractions, you just multiply straight across. Like this. What's half of 2 whole pies? You heard me. 1. Say 1. What's half of 2 whole pies? Okay, watch this. 1/2 times 2 whole pies. When you say 2 whole, you can put 2 over 1. Say 2 over 1. Means 2. Half of 2. What's 2 divided by 2 is 1. Say half of 2 is 1. Say it. What's half of 4? What's half of 4? Now, when you multiply, look at me here, or look at the paper here, or look at whatever you want, for that matter. I don't really care. Because when I'm through with this, I go home and have my dinner. It's out of sight, out of mind. I hope they understood this. When you multiply fractions, you cancel one number with another number. It has to be a top-bottom cancellation. Y'all are hearing me? 2 goes into 2 one time, and the answer is 1. What's half of 6 children? If you're getting divorced and there's 6 children, you get half of them. How many kids you get? That's not a very nice thing to say, is it? That is a mean-spirited thing. You're going to go report me. I won't use that one. What's half of 6 Cadillacs? 3. And if you cancel, 2 goes into 2 once, 2 goes into 6, 3. 1 times 3 is 3. When you multiply fractions, you multiply straight across, cancel when you can. Is that clear? Is that clear? All right. I won't use crude stuff anymore. I'll be good, okay? Take care. Let's see who's pretty good. Can you add fractions? Say yes. Yes. What's the answer? Please tell me. I'm listening. I can't hear you. What's the answer? Say 2 over x. Say 2 over x. Right? When you add fractions, you need a common denominator. Write it down. Hey, what's 1/8 plus 1/8? Good. Which is 1/4. What's 1/8 times 1/8? I can't hear you. 1 over 64, yeah. 1/8 plus 1/8 is 2/8. 1/8 times 1/8 is 1 over 64. Are you with me? All right. How many quarters can you get out of $1? I say it again. How many quarters can you get out of $1? Say 4. You know that, don't you? What if you said 10? Huh? Okay. Quattro, si, yeah, right. Okay. Okay. How many quarters can you get out of a whole dollar? Say it. Say it like you mean it. Okay, watch this. 1 divided by a quarter. Say divide. When you divide, listen to me. I'm your teacher. My name's Ross. Listen to me. When you divide, you flip your fraction and multiply. Say flip the right fraction and multiply. Now what's 4 over 1? Say 4. What's 1 times 4? When I said how many quarters can you get out of $1, that was a division. And when you divide, you flip the second fraction and multiply. You understand? Hey, can you all add fractions? Say yes. Can you multiply fractions? Say yes. Can you subtract? Yes. And can you divide? With division, you flip. Okay, listen, here's a good one. This is on Jeopardy. I'm Alex Trebek. Listen to this. What's anything divided by itself? I can't hear you. Say 1. What's 5 divided by 5? What's 10 divided by 10? What's anything divided by itself? What's 1/2 divided by 1/2? Say 1. All right, watch this here. 1/2 divided by 1/2. It better be 1, hadn't it? Say flip the second fraction and multiply. You get 2 over 2, which is 1. Okay, look here. Old Ross taught you a few things tonight, or explained them to you. You can add fractions, you can subtract, you can multiply, and you can divide. Okay. Is that clear? Now listen. You got 2 kids at home. They each get $2.50 on Friday night. Okay? You got 2 kids at home. What's 2 times 2.5? Who can tell me what's 2 times 2.5? Say what? It is 5. Don't you have to have $5 to give each kid $2.50? Huh? Say multiply fractions. Say that. Now 2 is the same as 2 over 1. Times 2 times 2 is, plus 1 is. Now say cancel. 2 goes into 2 once. 2 goes into 2 once. 1 times 5 is your 5. So you can multiply even with mixed numbers. You just turn them into improper fractions. Is that making sense? Well, that is my little, review of fractions. that you can add, subtract, multiply, and divide fractions. You should be able to do all the fraction work in this book without any trouble. You could look at page, well, it's hard to say what page it is, but there's several problems with fractions on there. You should be able to handle them. Who feels comfortable with adding, subtracting, multiplying, and dividing fractions? Do you understand that? Do you all understand that's pretty good? Okay? All right. I don't see everybody's hand going up, so anyhow, if I can help you any more on that, I will help you. Okay? Now, next, let's make sure you can handle a little bit of decimal work here. I want to be sure that you can handle decimal work. When you add decimals, now who thinks they know the important thing to think about when you're adding decimals? Who thinks they know what's important to add decimals? That's right. For example, if I said 2 plus 1.5 plus 0.25, they might write it out just like that for you. And you'd have to be able to add your decimals. But I don't see a decimal in the number 2. Where is the decimal in the number 2? On the right-hand side. So I could do this. I could say 2 point, 1.5, and 0.25. As long as I line up my decimals, I'm good to go. Do you understand that? That's true of subtraction of decimals as well. Who understands how I added those decimal numbers up? Do you see what I'm saying? All right. If I wanted to subtract decimals, and they might ask you to do this without the aid of a calculator, you'd want to be sure you could do that. And the same thing is true with subtracting decimals. You'd want to line up your decimal points. Now, where's the decimal when you don't see it? At the end. So you could think 9.0, 1.6, and subtract. Are you with me? As long as we're lining up the decimals. In this problem, you're going to have to borrow, which I'm sure most of you know how to do. Borrow from the 9, make that a 10. Right? You borrow from the 9 and put the 1 over there, make that 10. Who sees that? Just like regular, 6 from 10, 4, 7.4. Is that clear? So adding and subtracting decimals, you just line up your decimal points. Is that clear? 2 weeks from tonight, I'm going to be doing algebra concepts with you. And I'm going to try to make them as smooth and simple and straightforward as I possibly can. So I hope you all will come next 2 weeks from now, and we're going to do the algebra concepts, and I'm going to try to make them as understandable as possible as well. So adding and subtracting decimals. Everybody see that? You line up your decimal points and just do what you have to do. All right, next. Is that clear? All right, now, what's half of a half? What's half of a half? 1/4, right? Is that right? 1/2 times 1/2 is 1/4, right? What's the decimal for 1/2? 0.5. Y'all understand? Say 0.5. Means 5/10 is 1/2. 0.5 is a half, right? 0.5 means 5/10. Say 0.5 is 5/10 is 1/2. So 0.5 times 0.5. Now look here, we're going to multiply. Say multiply. What's half of a half? What's half of a half? 1/4. Say 1/4. 0.5 times 0.5 is 0.25. With multiplication, we don't line them up, people. We do not line them up. You can multiply 5 times 5 and get 25, but then you got to count one space two spaces over. Do you understand? Do you remember that concept? You've got to count your spaces over. Does that make sense? You count one space, two space, so you got to go over two spaces, put your decimal point. Half of a half is a quarter, isn't it? So 0.5 times 0.5 better be 0.25. Do you see that? Who sees that? What's half of 6? Right, if I said 6 times 0.5, isn't that half times 6? Right? Say half of 6 is 3. Say it. 5 times 6 is 30. But I got to count over one space, and I get to 3. When I multiply decimals, let's see if you know what this is. What are 7 dimes worth? What are 7 dimes worth? Right, I multiply here and count over two spaces. You all see that? What would 0.10 times 0.7? Look here. Say 0.10 times 0.7. Right, well, you're going to get... But I have to count over 3 spaces. Are you with me? And that's my answer. You all see how that works? So when you multiply decimals, you got to count spaces over. Is that clear enough? Good. Okay. Then, how many quarters can you get out of $2? 8. Say, how many quarters can you get out of $2? Well, if I did that, if I said $2 divided by a quarter, the answer's got to be 8, doesn't it? Y'all see that? The answer's got to be 8. Well, here's the deal. When dividing by decimals, count over 2 here, and then count over 2 here, and then straight up. You see that? Count over 2, and go straight up. All right. Does 25 go into 2? Say no. Does 25 go into 20? Say no. Does 25 go into 200? Say yes, 8 times. And there you go. So okay, look here. If you have $1.50 and you have 3 children, how much does each kid get? If you have $1.50 and you got 3 kids, how much does each kid get? If you want to be fair now, if you have $1.50 and you have 3 kids, how much does each kid get? 50 cents, yeah. Okay. Put your decimal straight up, and you get 50 there. Okay. Now, tell you what we're going to do here. Now, on page number, look up here about 4 or 5 pages in. It says Fraction Review Practice 1. I'm going to just sit down for a minute while you do a little bit of this here. This fraction review, it says 66 on the bottom and 15 on the top. See if you can find that. It's a few pages in. It's a few pages in. There you go. It says, what I'd like you to do, listen, there's some that you can add, subtract, multiply, and divide. And the answers are all on the back side there. What I'd like you to do is spend maybe 5 minutes, just do some of each of those. See if you can handle some add, subtract, multiply, divide. And I'll just shut up for about 5 minutes so you can concentrate. And we'll see that you can handle this add, subtract, multiply, divide. It says Fraction Review Practice 1. Try some of those. The answers are on the back, so you can always check your work there. Try a few of those and see if you can talk amongst yourselves and help each other out if you want. But try some of those. Try some of those and help each other if you need to and check your answers. I'm going to tell you, I see some of you with calculators here. On the test, they very well will probably say don't use your calculators, so you better be able to do it without the calculators, because they may just absolutely not let you use them. I'm not sure, but I'm just telling you. They're not that hard that you really need a calculator with. Some of you have a little difficulty with your times tables, I assume, but do the best you can. Yeah, try some of these problems here. Help each other, people. We're just spending a few minutes on this. We'll go on something else here in a minute.
Can you have it like this?
Let me see here.
41 over 28? How do you borrow one?
Let me see what you got. Okay, so that's...
Like,
All right, 41 over 28 is improper.
right, yeah.
Say 41 divided by 28.
41 divided by 28.
Goes in there 1 and so much, you know.
Yeah.
So then you're going to, okay, so
Well, I know it's a 6, but then what happens to the rest of it?
1.
Oh, we used...
So it's 6 and 13 28s.
I see.
You understand what I'm saying?
Yeah.
Because what you got, there was more than one whole, and you had to add it on to the 5. So if you can handle these, you're in good shape with fractions. Let me tell you, if you can handle this sheet there, I'd say you're in real good shape with fractions. Real good shape with fractions. And that's what you want to be. You want to be in real good shape with fractions. No problem.
Improper fraction.
Yeah, you take 41 divided by 28,
Okay.
and that's 1 and 13 28s.
Okay.
You'll add it to the 5, it'll be 6 and 13 28s.
Okay.
Yeah, help each other out here, and there's a variety. Make sure you do an add, a subtract, a multiply, a divide. Make sure you can handle basically what we're talking about here. I want to see you do very well on this NLN test. What you got here? Question?
Shouldn't be, the 30 is on top, so it's like this.
Right.
So it'll be 1 over 30.
No, you're multiplying. You just do top times top. You only flip it when you divide. Only when you divide do you flip it. Do you remember that now? You don't flip with multiply. You flip when you divide. Hey, listen here, I don't want to spend a lot of time doing this, but you've had a chance to look at a few of them. You want to be sure that you can add, subtract, multiply, divide. And the answers are on the back. At this point, is there one you'd like me to show you? Any of you that you would like to see? How many of you are being pretty successful? Raise your hands if you're pretty successful, that you're understanding. Are you understanding it okay?
We over 18.
Okay, 18. Who would like? Yeah, 18. would you read 18 to me, please? Oh, here, I'll do it up here. You're on the back side? I was asked to do 18 on the back side of there, and I'm going to do it for you. With 18, you're dividing, and you got to change them into improper fractions. 5 times 3 is 15, plus 2 is 17 over 5, divided by 15 times 1 is 15, plus 2 is 17 over 15. Are you with me? Y'all see that? When you divide fractions, the second fraction gets flipped. Now, when you flip it, you can do some cancellation. Once you turn it into multiply, you can cancel. The answer is 3. All right, now look here. I want you to be able to handle add, subtract, multiply, divide. Now, when we're done, if you want to come and see me personally, because you don't want to say anything right now, that's fine. You can come and see me. But if you're really not too sure what you're doing, I'd appreciate you asking me right now, because I'm sure that if you have a question, other people might have a question too. So that's fine. Yes? Number 2, sure. Okay, can I do it right on my paper here? All right. You got to have a common denominator, which is 28. 7 goes into 28 4 times. 4 times 5 is 20. 4 goes into 28 7 times. 7 times 3 is 21. I add up, I get 5 and 41 over 28, right? Now 41 over 28 is improper. So I got to take top, divide by the bottom, goes once, with 13 left over, 1 and 13 over 28. Does that make sense? Now what's 5 plus 1 and 13 28ths? 6 and 13 28ths. Does that make sense? Okay. Before I move on, let's turn the page and let's see here. No, let's turn the page here. Okay. Okay, look here. Here's what I want you to do. Just so we're all sure we know what we're doing here. On this page, I want you to do number 3 to add. I want you to add with number 3. On the next page, I want you to subtract number 4. We're not going to do a whole lot. We're just going to do add, subtract. And then on the following page, do number 1 and number 9 and, well, let's see. I want you to do that problem and this problem. So in other words, 5 problems here. Let's do 3 on this page, 4 on this page, and then these 3 problems on multiply, divide. Do those 5 problems just to be sure that you can handle it. Okay? Yeah, if you can do those 5 problems and get the right answers, I'll feel reasonably comfortable about it. Now, it's to your advantage not to leave early, but if you do have to leave a little early, please don't forget to give me an evaluation so that we'll know whether we're hitting home with you or not. So hopefully you can stay for the last 2 little sections here, which are very, very helpful. But if for some reason you have to leave early, please be sure to give me an evaluation. Well, look here, time's getting by us. I'll tell you what, I want to have your attention for 2 more issues, and I want to get you out of here a little bit early if I can, but I need to move on at this point. You know what you need to be able to handle, and I'm going to stick around and help you if you need it. I want to talk to you a little bit about a percent problem and a rounding problem. So if you could give me your attention right now, I want to talk about rounding and percents, because they're going to ask you these questions. Let's see if we can be on the same page. You can go back and work on this later. Let's talk a little bit about rounding where you're sure what you're doing, because no doubt they're going to give you problems like this. You're going to want to be able to handle it. All right, if they give you the number 362.915 and they say round to the nearest 100, they're going to want to have the answer that they need, and hopefully you all would know how to round this to the nearest 100. Who thinks they know the answer to that question? 362.915, rounded to the nearest 100. Say 400. Just say 400. Now the way they do that, they look at the hundreds position and they look to the right. 5 or more, you round up. Under 5, you stay the same. When I say 362 rounded to the nearest 100, who understands 400 would be the answer? Do you understand me? Good. Question. All right, what if they said round to the nearest 10? What do y'all say? 360 is correct, Because if I look to the right, I see a 2. Okay? They're going to give you questions like this. You're going to have to know it. What if they said round to the nearest whole number? That would mean like round to the ones place. Who understands 363 there? Do you see that here? Huh? Does that make sense? 363. Good. To the nearest tenth. 362.9. Who basically understands that idea? That's how you're going to do it. Enough said? Enough said. Okay. The last thing, well, actually, I should talk to you a little bit about the geometry. In your packet there, you've got perimeters and areas, and you can see towards the end of that packet, you'll see some geometry, and you'd want to know perimeters and areas. Most of it's pretty self-explanatory, okay? But one of the problems people have is percentages. Percentages give people a headache when really it shouldn't give them a headache. It shouldn't give them a headache. Here's the deal. With a multiplication problem, factor times factor equals product. All right. 8 times 2 equals blank. 7 times blank equals 35. Something times 9 equals 27. I have 3 multiplication problems on the paper in which I've left out one number. You see what I'm saying? I've done 3 multiplications on the paper in which I've left out one number. Let's see if you can tell me in a concise statement, plain and simple. When missing the product, what do you do? One word. Multiply. Do you all see that? When missing a product, you multiply. The answer is 16. Do you all see that? So if I said, I'm missing my product, what would you tell me to do? Multiply. When missing a factor, one word, what could I do? I could divide. When missing a factor, you can divide. You can think 35 divided by 7, and you could say 5. Is that clear? When missing a factor, you can divide. Who understands that? Do you all see that? Okay. One thing that gives people trouble is percentage problems. One thing that gives people trouble is percentage problems. And they don't have to give you trouble. Watch this. Watch this, sir. Now here's a percentage problem, oftentimes written just like I've written it here. 50% of 40 is what? You see what I'm saying? Now say, rewrite that. 0.50, what does of mean? Times 40 equals something. Say missing a product. I can multiply, can't I? I can multiply 0.50 times 40 is 20. Hey, what's half of 40? Right, you could have done it that way. Are you with me? With a percentage problem, just rewrite it. Watch this. 30% of 30 is what? Say, rewrite that problem. I could say 0.30 times 30 equals blank. Say multiply. The answer is 9. 30% means 30 over 100 times 30 is 900 over 100, which is still 9. When you have a percentage problem, You just work it as a multiplication problem. Watch this. 50% of what is 11? Say, rewrite that problem. I'm going to think 0.50 times something equals 11. Right? Am I correct? Say missing a factor. When you're missing a factor, one word, what do you do? Divide. So you say 11 divided by 0.50, correct? Say move the decimal. The answer is 22. %50 of 22 is 11. What's half of 22? 11. I rewrite the problem. How do I find a missing factor? Say divide. I take 7, divide by 0.25. How many quarters can you get out of $7? Say 28. Say 28. The answer is 28. What percent of 12 is 9? Say rewrite. Something times 12 equals 9. How do you find a missing factor? One word. Divide. Now the product sometimes is smaller than the factor. Sometimes. The product sometimes is smaller than the factor. That's okay. Life is like that. What am I going to do? Okay. Decimal point. All right, see what you could do with this here. Here, see who can tell me the answer to this one. I'm going to give you one to do. I'm going to just say it out loud. You write it on your paper. See if you can do it. %60 of what is 18? Who's got the answer? Don't all raise your hands at once. Come on. 60% of what is 18? Okay, some of you do. I'm going to start to work it for you. Who understands where I'm going with this? Say the answer, please. 30. That's right. Because you divide. %50 of what is 12? 50% of what is 12? Try that one. right? Y'all see that? Half of 24 is 12, right? All right. 3 parting shots. I want to get you through by quarter after here. 3 parting shots. Look at here. 4-sided figure called a square. 4-sided figure called a square. I want you to tell me what's the measure of one angle of a square. 90 degrees. Who understands that? Who understands 90-degree angles? Do you understand? Listen to me. I want to tell you something here. All 4-sided figures have a total of 360 degrees. Say 4 times 90 is 360. All 4-sided figures have 360 degrees. Are you with me? Any force, I don't care what it looks like, strange or whatever, all the angles add up to 360. Does that make sense? Are you with me? Say half a sandwich. Say half a sandwich. That makes a triangle, doesn't it? Doesn't that make a triangle? Watch this half a sandwich here. How much is this degree right here? 45. It's half of that angle, isn't it? Any triangle has a total of 180 degrees. Does that make sense? Right? Now, I've done the best I can to get you pretty much going with things. I want you to work on this worksheet to the point that you're comfortable with it. Now listen to me. If you come across things that give you a little trouble, you make the effort to get into the ASC, get someone to help you straighten yourself out. I'm telling you something, listen to me. If you know this material, you're going to do a whole lot better on the NLN test. And that's what I want for you. 2 weeks from tonight, I'm going to cover some basic algebra with you. I'm going to try to make it as easy as I can, as straightforward as I can, as I want you to have a really fighting chance to do very well on the NLN test. I want you to do well. If you would be so kind as to do a little evaluation. Once you do your evaluation, just put it right here on this table here, and I'm going to dismiss you at this point. And if you have questions, I'll help you out with any questions that you have. Just put your evaluations here, if you would.
Thank you so much for coming out.
Did it help you?
Yes.
Oh,
yeah.
that's wonderful.
I'm going to be going to the ASC lab to just getting clarified.
Absolutely.
It has been a while since I've
Well,
done
yeah.
most of this.
Did
so.
it kind of come home to you what we talked about?
Yeah. Like you broke it down like very simply to the very beginning of it. So.
I hope so.
Yeah. Thank you so much.
You're welcome. Thank you for telling me that. Did it help?
Yes.
Oh, that's great. Did it
It's much
help?
needed and very helpful to get it all back fresh in my
Well,
head.
good. Now, you take the time necessary to go through all that stuff.
Oh, I will.
And anything that's giving you trouble, get right up to the ASC.
Most definitely. I
And what
will.
I'm going to do next, 2 weeks from tonight, we're going to cover some very basic algebra. That
I'll
will
be
help
here.
you. You better.
I've already scheduled everything from now through May to make sure I'm on top of all of it.
Well, good.
Because I need that. I mean, I haven't done the math now in almost 2 years. So it's like, okay, I definitely need this refresher to get it back in my
did
head.
it come home to you?
Oh, straight home.
Oh, that's
Straight
wonderful.
home.
I'm so glad.
Thank you very much.
You're welcome. Thank you.